Hey everybody, this is Larry. This is day 21st of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Hope everyone had a good, well, if you're in the US anyway, day off for Martin Luther King. There's a lot of things to be said. I'm not going to get to it today, so yeah. And that's all that happened today. So let's take a look at today's problem, 2017 grid game. All right, so you're given a zero indexed 2 by n grid. Okay, you have two robots. Both start at 0, 0. One want to go to the other corner. Okay, you can move right or down. Okay. At the start of the game, the first robot moves from 0, 0 to 1 n minus 1. Okay. And then the second robot goes after the first one goes. The first robot wants to minimize the number of points collected by the second robot, where the second robot wants to go. Okay. Is it just greedy? I mean, not greedy in that sense, but I mean, greedy in the sense that, robot 1 wants to optimize just taking a lot of points. But in any case, I think the one thing to observe about this problem is that there are only two rows, right? What does this mean? This means that there's only one choice, right? I mean, there are only two pictures, and they try or three photos actually, three examples, and they try to not draw attention to it. But really, you only have one choice, and it is that when do you want to do the swap over, if you will, right? From the top to the bottom. And once you kind of realize that, then then now you look at n, I think. Okay, n is 5 times 10 to the 4th. So my first thought, honestly, would have been to kind of just be like, oh, can we do some n square thing, right? Meaning that, okay, well, if the first player or the first robot drops down at index x, what is y strategy and so forth, right? So there are kind of things like that, and that would be n squared if you do it very naively. But you probably can do it in better than all of n squared time. It's just that, sometimes you just want to do it the stupidest way possible in a good way because it's easy to implement. But okay. Then the idea then is I mean, this is still somewhat game theory. There's maybe a little bit of a mini-max. I mean, I think the way to visualize it, and I think I'm visualizing it, but let's draw it out. I think it's actually not. I mean, I think it's interesting for sure. I think there is a thing that you might not notice until you draw it out. I mean, I think I drew it out in my head. That's why I say that it's a very awkward phrasing that I'm saying. But in any case, until you draw it out, sometimes it may be a little bit tricky. So this is what I'm going to do, right? So basically, you have a 2 by n grid, as we said, and that means that in a way, you only have to make one decision for each player, which is that when to drop down, right? Well, what does this mean? Let's say that player 1 has done this red move, right? And it's just a random move, right? Well, what does this mean? That means that honestly, then player 2 only has 2 moves, right? I mean, yes, player 2 can have more moves, which is maybe something like come here, but I mean, you don't have to be super attentive to now with the visualization to realize that if you do something like this, it always is more optimal to do something like this, right? Obviously, and you do the same thing with the other way, and so that because there are only two rows, then now it really is just that well, player 2 can make 2 moves, 2 distinct moves anyway, 2 good moves, which is either this one or this one in effect, right? And that's pretty much it. So then now I mean, now we just think about how can we answer these queries in a good way as we let's say we brute force this middle point now, right? O of n, just try everything once. Then now, can we answer these queries, the brew queries of, okay, what is the sum of this chunk and what is the sum of this chunk? And then just do a comparison. And that's it. That's all this problem now comes down to. Now, as I say, if you draw it out, once you draw it out, I think it's actually not that bad and pretty straightforward in terms of what next move mean, right? But of course, a lot of these things are easier said than done, and it took me a little bit of too, as you see. We're just thinking about it, right? So okay, and yeah, yeah. There are a couple of ways to, okay, so maybe we'll even do something like really, yeah. Remember that you only given, or you only need to solve the problem you're given. And what I mean by that is that don't try to be too, I mean, maybe you can if you really want. You don't have to generalize it for more than 2 rows, right? And in fact, you really can't easily. So just, if you have to write your code, it's okay to write it specific to 2 rows. So okay, so top row sum maybe is equal to sum of grid of 0, right? And maybe bottom row sum is equal to sum of grid of 1, right? And then what? And then now maybe we have something like right? Where I guess it's not n, it's c. And we just have to be careful, right? Because then now, let's say, yeah, so best is equal to infinity, which is the number of, okay, oh yeah. Oops, actually it should be 0, right? For your 2, I don't know how that keep on pasting, but, and then the idea here is that now we just keep track of, you could keep track of things in a number of ways. You could use prefix sum if you even want to. We talk about prefix sum a lot. That is definitely a hammer that you could use to smash it. But we can actually just do regular sum, right? Because you have the sum, which is the entire row, and then you know the sliding window of what you're progressing, and also for top and the bottom, so that should be good, right? So yeah, so current top is you go to 0 maybe, current bottom is equal to the entire bottom row sum to begin with. Technically current top should be grid of 0. Oh sorry, 0 because you count the top, right? So then now this assumes that you're going just straight up down the one, right? And of course in this case the score would be, let's write it out. The score would be top row sum minus current top plus, or actually not plus, because you assume player 2 or robot 2 would do the smart thing of choosing the max, so that's what they would do, right? So they either take the bottom row sum, well in this case they wouldn't because that's 0, but you know, I like to write it out. And then yeah, and then now as you slide, almost like a sliding window, just look at it 1 dimension at a time independently. In the top row you added a thing, so we added to grid 0 1, and then current bottom we actually subtract the previous one actually, right? So grid of 1 of I minus 1, right? Oh, why did I say 1? It should be I don't know why I keep on. Okay, and then now the score is also the same thing. Oh, I guess score is the same thing, but here we want to maximize the score, right? So that here, and here, this part we can copy and paste. Maybe we could have been a little bit cleaner, but and that's it. In theory, I make a lot of mistakes, like this one apparently. But in theory, the idea that would be the idea. What am I doing wrong? That I'm confusing. I get 9 and expected 4. That is actually not great. Current bottom. No, that looks okay. Yeah. So then, oh, it's not bottom row sum anymore, is it? It is. No. It gets larger. This makes sense. Huh? I don't know why this is. So all right, let's see. So then now we just print I and then score. Oops, did that happen? Right, so here at index 1 we have 4. Oh, actually, I mean this is fine. But at index 2 it thinks it's 6, which is also a little bit awkward because that is both wrong and also it's even wronger here, right? Why is that? What did I do wrong? Where did I go wrong? So this part is 0, current top is going to be just 9. Oh, this is max. Okay, I mean, I think I got the logic wrong actually. So it's not actually the code, because I was just a little bit lazy and going fast as we were talking about yesterday. We have to think about it a little bit because basically, with your player 2, of course you'll maximize this, right? But here, what we want is that we actually want to minimize this. We want to actually is a min because player 1 is choosing the score. Basically, player 2 doesn't have to choose a score. Player 2 just choose, if this choice is taken, it'll take it. So this is going to be the score essentially. So player 1 gets to choose, so player 1 is to minimize. So actually this is a minimization problem. I messed this up. I kind of was talking to it. I was kind of speaking through it, but then I don't know. But it was an easy fix. If it's right. Dong dong dong. Oh, I still have this. Oh, yeah, there you go. Very silly things, Larry. Alright, let's get a quick submit. Hopefully it's right, and yes. Okay, so not that, okay, still slightly not great, but yeah. That is all I have for this one. And let me know what you think. Yeah, this is gonna be linear time, constant space. You can look at it and kind of figure that out. So yeah, that is all I have for this one. Yeah, thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.